All right, part number 2. So now we're going to go over question number 2. All right, first of all, we changed the balanced equation, didn't we? I should have erased that. So we've gone to a different equation. So now we're looking at the equation of 2 C2H2s plus 5 O2s will form 4 carbon dioxides and 2 waters. All right, so there's my balanced equation. That's my recipe. So we go to 2, letter A. It says how many grams of carbon dioxide? So we need to know X grams of carbon dioxide and water. Oh man, we got to do 2 problems here. And grams of water. Okay. Are produced when 108 grams of C2H2. So we got 108 grams of this guy. So we're doing mass to mass, but we're doing it twice. So let's do this guy first right here. So we're going to go 2 carbons times 12 plus 2 hydrogens times 1. All of that times 2 to get its molar mass. So this one's molar mass is 52 grams. Now we'll do the molar mass of this one. 1 times 12 for the carbon plus 2 times 16 for the oxygen. All of that times 4. So that ends up giving me 176 grams. All right, set up my molar mass ratio. 52 grams of C2H2 will make 176 grams of carbon dioxide. So that came from the balanced equation with the molar masses. And then I got 108 grams of this guy over X grams of CO2. All right, so cross multiply 52 times X equals 176 times 108. Divide by 52, divide by 52. And X is going to end up equaling 366 grams of CO2. I'm going to write this up here anyways. 366 grams of that guy. That's what we end up making up there. All right, so now let's do the second part. Now let's figure out the water. All right, so I'm going to erase this because I'm going to get off the screen if I go over too much farther. So to do the water, we got to find out its molar mass. So we have 2 hydrogens times 1 plus 1 oxygen times his mass is 16. All that times 2. So if you multiply that guy out, you get 36 grams of water. So now we set up that 52 grams of C2H2 will make 36 grams of water from the balanced equation. Well, then I got 108 grams of the C2H2 will make X grams of water. Cross multiply 52 times X equals 36 times 108. Divide by 52 on both sides. And X ends up equaling 74.8 grams of water. So this is 74.8 grams that we're making up there. All right, so there's the answers for the first one, letter A. So now let's go to letter B. Letter B says, how many grams of oxygen are required to burn 108? So now we need to know X grams of this guy. Oh my word. And we're still using this 108 grams of this one. So I'll leave everything else up there because I think it's going to help us on letter C. All right, so we need to know the molar mass of this one. So we have 2 times 16 for the oxygen. All of that times the 5. That's out in front. So if we do that, let me flip the page over. So that one's going to be 160 grams of oxygen. So I have 52 grams of C2H2 needs 160 grams of O2. Right there, that's from the balanced equation. Well, then I really have 108 grams of C2H2. We want to know X grams of O2 that requires. So cross multiply 52 times X equals 160 times 108. Divide by 52 on both sides. And X is going to equal 332 grams of O2. So this one's 332 grams of that guy. All right. So that was letter B. Now letter C says use the answers from number 2, A and B to show the law of conservation of mass. Well, law of conservation of mass, remember, says if I take the 2 reactants, take these 2 guys and add them together, then they should be equal to these 2 guys added together. If we add those together, we get this side over here is 440. This side over here is 440.8. That's pretty close, right? I know we end up at that 0.8. That all has to do with that significant figure piece. Okay, so it does show that they are equal. We can even look at their molar masses. If I take these two numbers, those should be equal to these two numbers, which, yep, those are also equal. Because this side is, what is that, 212, and this side over here, 212, right? So those equal out also. All right, well, that concludes this set of homework. So we'll see you in the next video. Have a great day.